Our developmental computational model then predicts that there are no meaningful input differences across SES when it comes to learning this syntactic island knowledge from this part of the input. Okay, great. What's useful is because we know how the input is predicted to cause that knowledge to develop, we actually know which building blocks in the input are particularly important for acquisition success. So in particular here, key building blocks for success involve complementizer that, so CP that, for short complementizer phrase that. And this is because two of the islands, whether and adjunct islands, only differ from grammatical WH dependencies by the complementizer used. You can see this here. What does the teacher think that Lily forgot is the grammatical dependency? It's an embedded dependency, a non-island structure, versus our embedded dependencies with the island structures really only differ, and the verb, of course, as well, but the structure itself by the fact that it's whether Lily forgot or if Lily forgot, right? So you need to realize that CP that is grammatical, but CP whether and CP if, not so much. That means you need to encounter CP that in your input, right? And so, in fact, we can really see this difference if we look at the container node sequences that characterize these WH dependencies. They only differ by the fact that this is CP whether and CP if rather than CP that. So children need to encounter grammatical WH dependencies that involve CP that. And it turns out that these are actually pretty rare in child-directed speech. So in both of our input samples, there are only 2 instances total, right? Even though we actually had quite a lot more of high SES child-directed speech. Both of the instances in high SES child-directed speech were, what do you think that Jack read? Something like that. So an embedded clause object, versus for the low SES child-directed speech, both of them were of this form. What do you think that happens, where we have an embedded clause subject, actually, with a complementizer phrase that, right? So they're pretty rare. They make up, less than 0.01% or 0.05% of the input. So, with enough input over several years, though, even these rare cases are predicted to support learning if you see you have enough time to encounter these things. And in fact, if the samples are reasonably accurate, low SES children actually see this building block more often, right? 0.05% is greater than less than 0.01%, right? So they're seeing it more often. And what's interesting is that here, what do you think that happens? This WH dependency with this building block actually, in the low SES child-directed speech, is typically judged to be ungrammatical. In the high SES dialect, this is what we canonically call a that trace violation. High SES dialect speakers generally don't like it. What do you think that happens? Kind of makes us squidgy, right? So the upshot is that low SES children are predicted to achieve the same learning outcome as high SES children by leveraging crucial building blocks from sources a high SES child wouldn't hear, right? Why? Because again, these sources are ungrammatical for high SES speakers. This is ungrammatical, but it's in the low SES child-directed speech, and it has that key building block which allows low SES children to succeed in acquiring the same outcome, right? The same syntactic island knowledge. So the takeaway is that this is one reason why differences in the input might not be meaningful differences. In this case, the building blocks may show up in different places, but they're still present in the input. And that's very powerful.